In the previous section, we looked at certain types of sequences called arithmetic sequence, where each term was found by adding the same number to the previous term. So if you started out with 3, 3 plus 3 is 6, and that same number being added would get you the next term after that. So this sequence right here is certainly not an arithmetic sequence. You don't add a certain number to each term to get the next one. This is an example of what we call a geometric sequence. And a geometric sequence is a sequence where each next term is found by multiplying the previous term by the same number, what we call a common ratio, that we generally use R for short. So if you look at this example and you take two consecutive terms and you divide the latter by the former, 6 divided by 3, you get 2. And if you take 48 and 24 and you divide the latter by the former, you also get 2. So your common ratio here is 2, R equals 2. So this is a geometric sequence. I'm going to leave some space because we're going to do some work here, but another example that we're going to do in a few minutes, that we're going to come back to, I should say, in a few minutes, of a geometric sequence would be the sequence 2, -4, 8, -16, 32, and -64, and so on. And in this one, the same number has to be continually be multiplied by each next term. So if you did 8 divided by the term that came before it, and you get -2, and you take two other terms, -64 divided by 32, you also get -2. So your common ratio in this geometric sequence is -2. Okay, just like in the previous section, where a big part of geometric sequences and arithmetic sequences is finding a formula for your a sub n's, we're going to do that here too. So we want to find a formula for our nth term. That way, if we're asked to find out what the 17th term is, we don't have to list out 16 before it and then multiply. So to give us some room, I'm going to erase this previous example, example number 2, and we're going to come back to it. Great. Okay, to find a formula for the a sub n's, in green, I'm going to do kind of like the background work, and then we're going to come back and do it the shorter way. So let's see, our first term is 3, and our second term is 3 times our common ratio, 2, to get 6. Our third term is 3 times 2, and then that needs to be multiplied, so that's the 6, by the common ratio. 6 times 2 is 12. Okay, the fourth term. We have 3 times 2 squared, if we're looking at the previous term, multiplied by another 2, another part of our common ratio, to get, I'm going to write this as 3 times 2 cubed before I write it as just 12 times 2, which is 24. Because remember, my hope here is that we see a pattern, we can find a formula for our nth term. Okay, let's do maybe 1 or 2 more. The fifth term is the previous term. Instead of writing 24, I'm going to write 3 times 2 cubed times the common ratio, so 24 times 2. Now I know that's 48, but I want to look for the pattern. So this is 3 times, let's see, 3 2s, 2 more 2, 1 more 2 is 4 2s. Okay, one last one. The sixth term is 48, or 3 times 2 to the fourth, times another common ratio, so 48 times 2. I know you all know that's 96, but to look for the pattern, I'm going to rewrite this as 3 times 2 to the fifth. And it's that second to last step that I'm going to look at in order to figure out my formula for my a sub n's. So let's look at that. For the sixth term, we always multiplied by 3. Remember where 3 was our first term. And we multiplied by a bunch of 2's. And 2, for this example, was our common ratio. Okay, so we had, for the nth term, we're going to start with our first term, 3, multiply by a bunch of 2's. Now let's look at the exponent on those 2's. The exponent, when n equals 6, the exponent is a 5, one smaller. When n equals 5, the exponent was a 4, one smaller. When n equals 4, the exponent was a 3. So, for the generic case of just n, whoops, that got a little too big, we have 2 to the n minus 1, one smaller. Erase that a little bit better. Two to the n minus 1. Cool, and there's our formula for our nth term. So in general, the formula for the nth term of a geometric series is your first term times your common ratio to the n minus 1. If you have that formula, then you can do, let's say this is part A, where we find the formula for the a sub n. Part B, you can now find the 10th term of the sequence we have up there by just doing a sub 10 equals 3 times 2 to the 10 minus 1. Clean that up a little bit. Or 3 times 2 to the 9th. Now, when you're doing these, make sure that you're using order of operations. So do 2 to the 9th first, which is 512, and then multiply by 3 to get 1,536 for our 10th term. Okay, let's do 2 more relatively quick examples. Okay, remember that example 2 that we were looking at last time? It was the geometric series 2, -4, 8, -32, and so on. And from dividing the 2 consecutive terms, like -64 divided by 32 to get -2, or -4 divided by 2 to get -2, we found out pretty quickly this is in fact geometric. So it's always the same number we multiply by, and the common ratio r is -2. Okay, so let's say that the question for this was, what is the 15th term of this sequence? Well, instead of listing out all 15 terms, the first thing that we would want to do to answer that question is to find a formula for our a sub n's. Okay, so remember, we're going to use the formula we had before. A sub n is a sub 1 times r to the n minus 1. That's the formula that we're going to use because we have a geometric series, or sequence, pardon me. Okay, so in this one, let's see. Well, our a sub 1 is nice and easy. A sub 1 is given to us. It's 2. So a sub n is equal to a sub 1 times r to the n minus 1, which is 2 times r to the n minus 1. Oh, and r, we also found out, r was negative 2. We found that by dividing two consecutive terms. So there's a formula for our a sub n's. If, though, the question is asking for a specific term, then in step 2, all we do is plug in n equals 15 into our formula. So a sub n is equal to 2 times negative 2 to the 15 minus 1, which would be 2 times negative 2 to the 14th. Remember, do your exponent part first and then multiply by 2 later. So negative 2 to the 14th power is going to be a positive 16,384 because 14 is even. And then times that last 2. Whoops, I'm writing a sub n's. I need to fix that. These should be n is equal to 15. Let's get that right. So the 15th term when n equals 15. And 2 times 16,384 is 32,768. Great. Let's do one final example. Okay. For our last example, let's look at the sequence 1/2, 1/6, 1/8, 1 over 54, and so on. And kind of similar to example 2, let's find the 12th term. So for starters, let's make sure that this is in fact geometric. So take two consecutive terms and divide them. 1/6 divided by 1/2. So that's 1/6 times 2 over 1, which is 1/3. And then just for the sake of room, let's do these two, 1 over 54 divided by 1/18, which is 1 over 54 times 18 over 1, which is also 1/3. Okay, cool. So our common ratio is 1/3. So we continually multiply by 1/3. And remember, we're going to use our formula here since it's a geometric sequence. The first term times r to the n minus 1 for the nth term. So the nth term, the first term we know is 1/2. R we just figured out is 1/3 to the n minus 1. So that's our formula for the nth term. To find the 12th term, this was step 1. To step 2, we're going to plug in n equals 12 into that. So this will be 1 over 2 times 1/3 to the 12 minus 1. Or 1/2 times 1/3 to the 11th. Okay, so this is 1/2. Now, since this problem was given to us in terms of fractions, we probably need to answer in terms of fractions. So 1 to the 11th is 1. 3 to the 11th in that denominator is 177,147. And then multiplying those two fractions straight across, we get the numerator's great. 1 times 1 is 1. 2 times 177,147 is 354,294. And that was our 12th term.